Good day, everyone. This is Teacher Justina, and welcome to my YouTube channel. If you are new, then do not forget to subscribe, like, share, and do comment below and hit the notification bell for more video updates. Okay, so our video for today is all about discriminant of a quadratic equation. So when we say discriminant of a quadratic equation, this is all about describing the roots of a quadratic equation. So let us explore. Okay, so for the definition, the discriminant of a quadratic equation is used to determine the nature of its roots. Okay, before we used to factor out quadratic equation and we cannot describe the roots if they are real, they are imaginary, or there is only one real root, not unless we will be using all the methods in finding the roots. So the different methods in finding the roots are the extracting the square root, the factoring, completing the square, and the quadratic formula. But this time, it's no longer to find the roots then describing it. We can now describe it directly uh, by getting the answer to the formula, which is being described by the discriminant, which is b squared minus 4ac. And remember that the b squared minus 4ac is extracted from the quadratic formula. Okay, so when can we say there are two real solutions? So when we say real solution, that means there are two roots, and real, when we say real, it's not an imaginary number. So when the b squared minus 4ac, or if our discriminant is greater than 0, that means positive. So if the result of b squared minus 4ac is positive, then we will be expecting that we have two real solutions. And then if our b squared minus 4ac, or if our discriminant will be equal to 0, there will be one real solution. And we will into this discussion why there is only one real solution, where in fact the quadratic equation has always two roots. And then when b squared minus 4ac is less than 0, that means negative, then there is no real solution. So no real solution. Okay, so let us have this example. Okay, so let us try this example. Find the discriminant of 2x squared minus 3x plus 1 is equal to 0. Okay, so far in finding the discriminant of a quadratic equation, first thing to do is we have to set the equation into its standard form. And so far, this is already on its standard form, no? 2x squared minus 3x plus 1 is equal to 0. And then for that, we can now get the value of our a, the b, and the c. Okay, so far using the formula b squared minus 4ac, then we are going to uh, find. Okay, our b is negative 3, so negative 3 square, and then minus 4 times our a is 2, and our c is 1. And so far to further simplify, we have a 9 minus 8, and for that, our d is equal to 1. So therefore, our discriminant is equal to 1. And since 1 is greater than 0, so as you have seen in here, if our b squared minus 4ac is greater than 0 or a positive, then there are two unequal real solution. So the one there is greater than 0 and then at the same time perfect square, then we will be expecting that there are two unequal real and rational roots. Okay, if we want to check this further, if there are really two unequal and rational roots, so far the 2x squared minus 3x plus 1 is equal to 0. The factors are 2x minus 1 and then x minus 1. And if we will be using the FOIL method, we will be getting this quadratic equation. And for this, the value of our roots will be x is equal to positive 1 half. This will be for our first root. And our second root will be, the negative 1 will be transposed. Our second root will be 1. So it is really correct that there are two real 1 half and 1, they are real and they are unequal and they are rational roots. So when we say rational roots, it could be expressed into P over Q. Okay, so therefore it is really true. Well, anyway, if we will be getting the discriminant of a quadratic equation, it's no longer needed to get the roots, but we are just simply describing the roots. What I am trying to emphasize, if we want to check really if there are two real and unequal roots. So far, let's proceed to the second example. The second example is x squared plus 100 plus 21x is equal to x. And so far, the x will be transposed and it will now become x squared plus 20x plus 100 is equal to 0. And for our a, we have a 1, and our b is 20, and our c is 100. So to use the formula, so b squared, our b is 20, we square it, minus 4 times, our a is 1, and our c is 100. Thus 20 squared is 400 minus 400. So our discriminant is equal to 0. So our discriminant is equal to 0. And it falls in here that if b squared minus 4ac is equal to 0, there is a repeated real solution. So again, if the discriminant is equal to 0, there are two repeated roots. So what do you mean by two repeated roots? Because quadratic equation, it has always two roots. So remember that the x squared plus 20x plus 100 is a perfect square trinomial in which the factors are x plus 10 times x plus 10. So therefore, our first root will be negative 10 and our second root will be negative 10. So is it really true that if our discriminant is equal to 0, there is a repeated real solution? There are still two roots, but they are exactly the same. So I hope the second description is true to this example number 2. Let's proceed to example number 3. So x squared minus x is equal to 3x squared plus 4. Okay, so again, we will be adjusting them into uh, quad standard form. So the 3x squared will be transpose, and then we have already uh, x squared minus 3x plus x minus 4 is equal to 0. And so far, the positive x, okay, I'm sorry, this is positive x. So x squared plus x rather is equal to 3x squared plus 4. So we were able to transpose the positive 3x squared, so it becomes negative 3x squared. So the x squared there is still the same sign. And then the positive x also, we're not transposing the x, so we have the x here. And then the positive 4 becomes negative 4 is equal to 0. And the x squared and the negative 3x squared can be combined because they are similar terms, and we're able to get a negative 2x squared plus x minus 4 is equal to 0. And to adjust them into standard form, we already agreed that our a, or our quadratic term, should be always containing a positive. So we will be multiplying this by negative 1 to both sides. That is why our negative 2x squared becomes positive 2x, our positive x becomes negative x, and our negative 4 becomes positive 4 is equal to 0. And for that, our a is 2, our b is negative 1, and our c is equal to positive 4. And getting our discriminant, we have b squared, which is negative 1, minus 4 times our a is 2, and our c is 4, thus 1, and then the 4 times 2 is 8 times 4 is 32, so therefore our discriminant is equal to 1 minus 32, and to further simplify, our discriminant is equal to negative 31. And so far, the negative 31 falls under this condition that if b squared minus 4ac is less than 0, so when we say less than 0, it will be negative. Then there is no real solution, because so far as we all know that the negative 31 is supposed to be on that radical sign, and there's no such square root of a negative radicand because this is an even root. And so far we are not yet on an imaginary numbers. So still, if you are to describe the roots, if the discriminant is less than 0, then no real roots. Let's have this another set of examples. 7x squared plus 5x minus 7 is equal to 0. And so far, this is already on its standard form. So our A is 7, B is 5, and our C is negative 7. So to use the formula, we have B squared. So B squared is, so our B is 5, 4 times 7 times negative 7. And so far, we have 25 minus 100, 4 times 7 times negative 7. And then we simplify the negative and the negative, we have a positive 168. And 168 plus 25 will gives us a discriminant which is 93. And remember that 93 is greater than 0 and 93 is not a perfect square. So if it is greater than 0 but not a perfect square, then there are still two unequal real but irrational roots. Again, if the discriminant is greater than 0 and not a perfect square, there are still two unequal roots. There are still two real roots but irrational roots. Unlike the perfect square, there are two real unequal but rational roots. So I hope have the you have to cite the difference between greater than 0, a perfect and a not perfect square. Okay, so let's proceed to the second example. So x squared plus 3x minus 18 is already on its standard form. So our A is 1, our B is 3, and our C is negative 18. So our discriminant, we have 3 squared minus 4 times 1 times negative 18. We have 9 plus 72. So our discriminant is equal to 81. And remember, 81 is greater than 0, and 81 is a perfect square. So how do we describe the roots? If it is greater than 0 and at the same time a perfect square, there are two unequal real and rational roots. Okay, so I hope you can now cite the difference between this example and this next example. Let's proceed to the last example. So the given is x squared minus x is equal to 3x squared plus 4. I think we are done with this already. So I think I need not to discuss it anymore. Okay, so guys, I hope you've learned something from my video today. And I hope if you want to learn more, please do uh, subscribe and leave your comment below and hit the notification bell for more video updates. Okay, so this has been Teacher Justina, and thank you for watching. That in all things, God may be glorified. Goodbye, everyone.